So we are currently learning a whole bunch of different properties that help us identify our different minerals. And two properties that are commonly confused or not well understood are cleavage and fracture. So let's talk about what these two are, just so that way you're clear on what they mean. Now, when we talk about cleavage or fracture, we're talking about the way a mineral breaks. So we're really just describing a breakage pattern. So in order to understand what we mean by breakage pattern, what we're really talking about is, and I know this kind of stinks to say it, but we're talking about chemistry. So if let's just zoom into some atoms. And let's say, here we have some atoms. And let's say they have some really strong bonds. The black bonds are going to be the strong ones. And let's say the blue bonds are very weak bonds. So let's say I was to hit this with a hammer. Would you be able to predict which direction this would break? Would it A, break along the weak or the strong bonds, or B, break along the weak bonds? If you chose B, you are correct. Right? If I hit this, it's going to break along that plane of weakness. So that's what we're talking about here. We're talking about where that plane of weakness is. And where that plane of weakness is what's going to show us where it breaks. So, let's first talk about cleavage. Cleavage only occurs where there is a weakness in the bonding structure, just like we saw a second ago. So again, right, if I have, right, that really strong bond in this direction, but really weak bond in this direction, I can predict that it's going to break right here. And it's going to break in a flat plane, right? So cleavage occurs in flat planes, right? Because it's going to occur this way. It's not going to occur this way and this way and this way. It's only going to occur in one direction. Now, when I talk about flat planes, you're going to see on your slide that you can have directions of cleavage. 1, 2, 3, 4, 5. There's a whole bunch of different directions. I only want to talk about 3 because I think 3 is well understood. So when I say 3 directions, I want you to envision a cube. And you're going to have to go with me here on my really bad drawings, because I'm not very good at this. So let's talk about a cube here. Okay, you know what I'm drawing here. So if you think of a cube, all right, a cube has 3 planes. It has a top and a bottom. The top and the bottom are in one plane. That's one direction. The sides are the second direction. The front and the back are the third direction. So think of that cube, right? Like I said, the top, right, and bottom. Oh, I can spell. That's 1. Okay. 2 sides. That's 2. And then the front and back. That's 3. So I want you to think about this cube, right, when we talk about different planes here. So when I say, right, something has one direction of cleavage, that means if I have a sample, right, let's say here's my sample, okay, here's my mineral, right, that I have, okay, and I'm gonna hit this with a hammer, it's only gonna break in one plane, in the top and the bottom, or the 2 sides, or the front and the back. So it's only gonna break off in one direction, right? It's only gonna break off in one of these. Now, if I have something that has 2 planes of cleavage, going to break off in two of those. So let's say here again, I have my sample. Right. So what's going to happen here is that maybe it's going to break along the top and the bottom, but then it's also going to break apart along the sides. So that means the top and the bottom are going to be nice and flat. The two sides are going to be nice and flat. But the front and the back, well, they're not going to be flat at all. They might be really, really bumpy. Now, the third possibility here is I might have something that has three directions of cleavage. So what that means, if I have something that has three directions of cleavage, is that it's going to break along all three planes. So that means, right, the top and the bottom are going to be flat, the two sides are going to be flat, and the front and back. So, again, right, what that means is the top and the bottom are nice and flat like a table, the two sides are nice and flat like a table, and the front and the back are solid. So that means we're going to have a cube. So, what you should take away from that is cleavage planes are flat. It's very easy to identify them because they're flat. Now, if you remember, we also had either cleavage or fracture. Fracture occurs where there is no weakness. Alright, so there's no weakness in the bonding structure. So what that would mean is, let's say I have something that looks like this. Right there are my atoms again. And so there, the black is, remember, the strong bonds. And instead of where we have weak bonds, we have strong bonds. So maybe we have strong bonds in all directions. Right? So there's no weakness there. So if I hit it with a hammer, it's just going to break. It's going to be very irregular. And that is the way to tell it apart. So cleavage has flat planes, fracture has irregular planes. Hopefully that helped you tell the difference between the two.